Okay. 34 students available, 32 students available now. How many have responded? That let me see that. Good number of people have responded, and let me also see the result as well. So class average is only about, overall average is only 1 mark. Yeah, out of 2 mark, 50% average. So in okay, Vignesh has answered. I'll take this thing. Okay, so sometimes this I'm considering simply attendance, but you can easily work out this problem at least, no? So how do you find the damping coefficient of the system for today's problem?
Sorry, just divide by 4, bring it in the standard form, and just equate coefficients.
Fine. Yeah, first one, this tau you can easily find, because tau square is 1 by 4, from which you can get tau to be equal to 1 by 2, and 2 tau zeta is equal to how much? It is 1 by 2 only. From that you can get. Yeah. So the otherwise I will close that. Quiz will be over now. Should be over now. Our time is over now. Otherwise also I will stop the quiz. So quiz won't be available. Okay, about 30 students available now. Good number. Okay, this quiz won't be available from hereafter. Okay, this yesterday I had to get a question or answer we need to know. So what is the gain of this second order system? Still many of you have answered wrongly. Though this question was asked in the test, and even many of you have answered correctly, or got a correct answer of. So what is the correct answer? I am referring to Rishita's response. Innoma correct answer enduma? Yeah, I will ask from some other students as well. Now, பேசுறது கேக்குதுல்லப்பா? Yeah, audible. I didn't change anything. So what is the gain of this process? The input is suddenly rising to a value of 1 step input. Step input of given at a time of say 1 time unit, and this units, the step size is 1. The settled value of the final output is nearly equal to 2. Then what is the gain of this process? The late varanga onum prachana illa, innora what is the gain?
2, sir.
2. Yeah, since you have answered correctly, 2 correct, Amma. And I am asking from the other students. How do you say it is 2? Audio clarity irukama check பண்ணுங்க. How did you say it is 2? Because
input step size is 1 and output step size AKP is equal to 2. AKP by A is equal to 2, sir.
Fine.
Gain.
So here already I said this A is simply 1. Yeah, A is equal to 1. A is a step size. A is equal to 1. KP equal to, so the A into KP is the output here. So it is equal to 2. So simply equal to KP equal to 2. Okay, no, the test la keta question ipo keta kuda neenga seriya answer panna maattireenga. Somehow no seriya varala, form ku varala. Okay, let us not spend much time on now, because already 10 nimisham poiduchu in the class la. We are going to today's class content. So last class la enga vittom and இடத்துல இருந்து ஆரம்பிக்க போறோம். Fine, now this screen is visible to you. Yeah, this is the maximum size I am having. So what is your objective? You want to keep the level constant. There is H to be constant. H a constant we have a setup to main raise. 1 minute. Yeah, right. So to make this H at a constant level, in spite of any changes in Fi or Fd, we have a measurement of level, this measurement, and which is compared with a set point. There is a comparator. We are simply comparing with the set point, and the difference is going to the error amount of error is going to the controller, and of course there should be a controller. Yeah, so that controller is acting on the control valve. Diagram diagram this is the diagram. Nice diagram is available here. No diagram right. So the level system input out. There are two inputs. One is Fi, another is Fd. 1 minute. Yeah, fine. So one is Fi and another is Fd, and Fi is under our control by the way of a measurement and controller acting on that. Whereas Fd, we don't have any control. What is called as a disturbance flow. Fi is what is called as a manipulated flow, manipulated variable. Okay. So here, this output, of course, is having a linear relation with the height. So we want to keep this level constant in spite of any changes in Fi or Fd. So at steady state, we have this relation. F naught is equal to Fi by d, Fi plus Fd. Whereas under dynamic conditions, this inflow minus outflow is equal to the change of volume in the system. Actually, change of mass for level system, for liquid system, we can take simply change of volume because density to be remaining constant. So, and again, by using this F naught equal to H by R, we have this relation and we have this form. So that is represented in terms of Laplace transform by this way. So otherwise, in terms of block diagram it is. So this H of, yes, there is an output variable of importance, is FIS multiplied by GPS and FDS multiplied by GDS. So otherwise, at this point, this value is, what is the value? It is this inflow multiplied by this transfer function. Likewise, at this point, here we have FD multiplied by GD. That is what is given here. Okay. So now we are going to manipulate this Fi by the way of from the from measurement and controller. 1 minute, I will. தேவையில்ல வீடியோல ஆஃப் பண்ணிடுங்கப்பா. ஓகே. So what we are going to adjust this. Otherwise, this Fi is a manipulated variable. We are going to manipulate that by what way? By having a measurement. So I'll again go back to the block diagram. So Fi is manipulated by taking the measurement, and measurement is compared with a set point, and this error amount is going to the controller. This controller is acting on the control valve. What is the final control element? Now, most of the time we will have this control valve as the final control element, because at last we are going to we are simply going to very fluid, no, by giving adding a mass or energy. So we at last will have most of the time we will be having a control valve as the final control element. So this flow diagram, we are going to it is not simply flow diagram, it is flow and this information flow. Not only material flow, there are information flow. So this is the information, and there is another information. So this controller, again there is information coming, and this is acting on the control valve. So otherwise these are all some sort of electric and pneumatic signals. So these measurements are electric and pneumatic signals. So that we are now going to represent this overall system in terms of a block diagram. I will write something. Again, better I will write this entire thing, whatever we did yesterday. So that at least I'm going to again draw this diagram. Another about 5 minutes to 10 minutes for this work. We want to have a level system. Of course, with a level system, then we will generalize. Okay, we have FD entering, and there is Fi entering. Let me draw it straightly. I need now. Okay, 1 minute. I'll clear this and keep it down. Fine. Okay, the level of the system is here, and there is a outflow which is having a resistance R and F naught. Okay, there is an outflow. So this Fi is manipulated in what way? Let me again clear this. You can also draw this. No? So Fi is manipulated. For that, we have a control valve. The signal to the control valve will be given by a controller. Before that, we have a measurement. I'll use another color for representing the signal at least. So level measurement, which is compared with a set point, say H set point. So this is plus and this is minus. So the error. So we have a controller, level controller. So that is the information given to the controller, and controller is acting on the control valve. So what is the information going to the controller? This is set point minus H measurement. So this is your error. So controller output is called as a C. So we have various blocks now. This diagram is visible, and H is measured by the level measurement. This level measurement. How do you measure the level of a system? Simply have this even pressure gauge also will give you a measurement of level. So level measurement, and what is the data going here? This is your H measured. So this is your H, and H is coming out in terms of HM. It can be H also, but so the what is the connection between H and HM? Say HM of S, there is output, and input is H of S, that is equal to Kp by tau P S plus 1. In the case of, so I say this is tau P, let us take it as tau M. No? 1 minute. Km by tau M S plus 1. So what is the meaning of this group? Say the measurement is having a transfer function. Say for example, in the case of a thermometer system, we take the measurement of temperature, and this measured temperature is not equal to the actual temperature. No? It's having its own dynamics. So otherwise, this is the transfer function of the measurement. To have a quick measurement, otherwise we need to have a very fastly responding measurement system. Okay, say for example, in the case of your thermometer, we need to have very small thermometer bulb and having a low capacity system, so that your tau P is what is tau P of the system, thermometer system? It is capacitance into capacitance into resistance. No? What is capacitance? MCP, and resistance equal to HA. So this is for a thermometer system. Likewise, for level system also you can connect. So this is your this about measurement and this actual variable actual H is the actual value of the height, and hm is the measured value of the height. I will clear this thing. This is not needed now. Okay. So what is LC? Okay, what is C? Okay, I will write everything in terms of now algebraic equations, and then we'll connect. Let us write the original thing. GP, there is a manipulated variable. So I'm going to let us write this 1 minute. That is, we want to derive, we want to get the closed loops, this block diagram. That's the objective. Okay. So for a general system y of s, we can write this way. This y of s equal to gp into m of s plus gd into d of s. So in what way this is connected? So in the last class itself, we have said about this. No, this h of s is having connection between this inflow and disturbance flow. This inflow multiplied by GPS and disturbance into GDS. So in that, for a general case, this we can write this h of, instead of h of s, we can write this y of s, which is the output variable, and instead of FIS, we can write a manipulated variable, and FD we can take it as a disturbance variable. Okay, so this only again represented here. Okay, so okay, how this manipulated variable is coming? Manipulated variable is before the manipulated variable we have. So this is where, what is a manipulated variable in the case of this level system? This manipulated variable is the inflow. Before that we have these blocks like measurement, comparator, controller. So we'll start from this measurement first. So H of, okay, H measurement, I'll use better white color, which is better. H measurement of S equal to H of S into this. For the measurement we'll have what is called as GM. GM refers to the transfer function of the measurement. Okay, so okay, this is the this measurement value HM, and HM is now turning as it is compared with the set point, and we have this error coming. In the comparator we have from the comparator we have, or let me this H instead of H again. Okay, HM is H set point minus HM. There is a error. Yeah. How do you say it is a error? Because we have HM has to be subtracted. We have the set point level and measurement level data is available, and according to the error amount, we will adjust the wall. So this is always, even without any controller, how does a person operate a plant? So simply he checks a level, and if the level is lesser than the expected one, what he will do, simply increase the opening of this wall. I'll use highlighted. So this increasing the opening of the wall. The same thing is now done by a controller. Okay, otherwise this controller can be a controller is simply a man or a computer control. Okay, in that way you consider. So this in terms of transfer function, it is HSP of S of minus HM of S equal to this error S. Okay, there is Otherwise, now we have come to this point. From this point, which is H, this H is now turning to. So this H is turning to HM at this point, and HM minus, sorry, HSP minus HM is the thing available here. That is given to the controller. Class கவனிக்கிறீங்களாப்பா? Maybe class கவனிக்கிறீங்களா இல்லைன்னு தெரியல. ஒரு இன்னொரு குவிஸ் வேணா போடலாம்.
Yes, sir.
Sure, thanks. Okay. And, if I put one more quiz again, it will be again distracting you. Okay. So what we have, this error is available now. Error is the input to the controller. Okay. So error is the input. Otherwise, see, I will try it again. So we have this H coming, and we have this diagram. Measurement from which we have this HM. This HM is now given, and which is set with compared with a set point. So we have this set point, and this error is subtracted. So there is what we have, this error is equal to HSP minus H. Okay, H not H, actually HM. Okay, and here we have a controller. So controller is having a transfer function of GC, and what is coming out is controller action, what is called as C. So C is the controller output. So otherwise, in terms of transfer function, C of S equal to GC multiplied by E of S. So what is E of S? E of S is already available here. Okay. And further, what is the connection between C of S and FIS? So C of S is nothing but the signal coming from the controller. This controller is now only acting on the control valve. So control valve also have its own dynamics. So control valve dynamics is there. So accordingly, this FI will be now turning out as FIS equal to. Let me draw the block diagram. Before we have this controller output, which is C of S, which is entering the final control element GF, coming out as the manipulated variable, which is FI. Or in terms of generic sense, we'll write it as manipulated variable. This MS refers to the manipulated variable. So otherwise, MS is equal to simply GF into CFS. Now these are all simply algebraic blocks only. So because of by using this Laplace transform, our differential equations are now turning out as simply algebraic equations. And whenever you have this output and input, you can simply relate them in terms of output equal to simply transfer function into the input. But everything is in terms of Laplace transform. That should be kept in mind. This final control element, most of the time it is a control valve, which is a pneumatically operated device. So this GF is normally a second order system. GF actually we should write like GP of S, sorry, GF of S. But again, better not to have so much of S. That's why we have simply GF. Likewise, GC. GC refers to controller transfer function, and GP refers to
So GF represents the pneumatic valve.
Yeah, pneumatic valve.
The final control.
Yeah, pneumatic valve. Fine. Okay,
so how do we? So MS is
manipulated variable. MS is the flow variable actually. MS is the manipulated flow, which is actually entering the process. So MS, or this is your MS. Correct?
Okay,
no?
sir. Yeah. Okay, sir.
Right. So என்ன பண்ண போறோம் இருக்கிற we have to connect everything and now relate in terms of a closed loop. So now we have arrived to MS. What is the final thing? So let me again write this everything. So otherwise I will write the equation again. We have, say, in terms of general system, I am writing this Y of S, that is the output variable of importance, Laplace transform of the output variable of importance. Again, everything in terms of deviation variable. Please keep that in mind. Y of s equal to GP multiplied by manipulator variable plus GD multiplied by disturbance variable. Everything transfer function multiplied by the corresponding input variable in terms of Laplace transform. Okay, so this is the thing we have. But now M of s is available in terms of GF into C of s. Follow பண்ணிக்கலாம்ப்பா?
Yes, sir.
Otherwise, yeah, right. Thanks. Otherwise, I'm using this ஒன்னு ரெண்டுலாம் மாத்தி எழுதிக்கலாமா? ஒரு நிமிஷம். So otherwise, let us start from here. No, yeah, this is 1. Again, 1 also you can write in terms of this general variable like y set point of s minus y measurement of s equal to error. Likewise, okay, everything other things are available in terms of general variables. 1, 2, and again 3 also will have. And this is our equation, capital 1. So using 1 in capital 1, what we are getting this, what is 1? 1 is, yeah, this is your 1. Okay, ysp minus, before actually we are using 3 in the equation 1, because 3 only is having m of s. So this m of s is nothing but manipulator variable, or is m, simply m. M is equal to gf into c. Okay, then the term அப்படியே தான் இருக்கும், ஒன்றும் மாற போறதில்ல. So let us not worry about that. So this g, what is c of s now? C of s is available as gc into gc into error. So otherwise gp gf, and what is c of s? C of s is available as gc into gc and error. Okay, plus the group அப்படியே இருக்கட்டும். And again, what is error? GP, GF, GC. Error is, what is the error? It is set point S minus Y measurement. Y measurement of S. Sorry. S எல்லாம் கூட வேண்டாம்னா ஸ்டாப் குறைச்சிக்கோங்க, தேவையில்லாம S போட வேண்டாம். Okay. So this is the thing we have. No. Again, we are not done with, because we don't have the value of what is OM, we don't know, because OM is coming from the instrument. So instrument has its own dynamics, whereas Y is the output variable of importance. So GP, GF, GC, YSP of S minus OM is coming from, what is OM? OM is available here. No, we have measurement. Yeah, measurement is yeah. See, here we have. One minute, we will be done within another few minutes. Okay, the OM of S is nothing but GM into Y of S. Simply the Y of S is the input to the measurement. It is coming out as OMS, which is OMS is equal to GM into Y of S. Okay, plus the group is available. Okay, now we can rearrange so that we can take this Y of S to one side. Y of S plus GP, GF, GC, GM. Otherwise, this entire right hand, we are taking this YM to the right hand side, which is yeah, 1 plus. I'll write it again better. So Y of S plus GP, GF, GC, GM, again Y of S equal to GP, GF, GC multiplied by YSPS plus we have GD, that entire group is available. GD and DFs is available. So again, you can group this in your, we are going to now write this to the final form, which is GP, GF, GC by 1 plus GP, GF, GC, GM multiplied by YSP of S plus What is there in the right hand? Another group is GD by this entire thing will be going down now. GD by this entire group. I'll write it again. Raise plus this is GD by 1 plus GP GF GC GM multiplied by D of S. So we are now done with. So what is the final form? This final form I'll again write it in a better way. Y of S equal to GP GF. Otherwise, no one 1 minute. We have GC GP G. I'm writing this same thing again. GC GF GP by 1 plus GC GF GP and GM Y SP of S plus GD by 1 plus the entire thing again GC GF GP and GM multiplied by D of S. Okay, இது என்ன பண்ணலாம்னா I can even represent in terms of a block diagram as well. So what is our original block diagram? Original block diagram. We haven't drawn the block diagram now. So our original block diagram was supposed to be this way. GD GP multiplied by manipulated variable. So this is our original block diagram. But how this MS is coming, it is from here, which is actually a manipulated variable. So this manipulation is coming because of a measurement. So measurement is having a transfer function of GM. So whatever is leaving is YS. So here also we have YS. Here we have YM of S, that is a measurement value that is still going. We have what is called as a set point YSPS. Okay, so GF GC. So here we have this error amount. 1 minute. I'll use another color. Here we have error, and here we have controller output. This is the manipulated variable. So now the diagram is, though we have already drawn the diagram. Actually, now we can connect everything. So the thing is now complete now. I'll explain this again. So we want to connect, we want to, we are relating these output variables in terms of manipulated variable and disturbance variable. And manipulated variable is the thing coming from the final control element. So manipulate that, we take a measurement, and the measurement is compared with the set point, and the error amount is given to the controller, and controller is working on the final control element, and we have the manipulated variable. So this entire block diagram is now simply represented in terms of this algebraic equation. So this algebraic equation represents the connection of these entire elements in the loop. And here, what is a loop here? Loop is coming because of the measurement and comparison with the set point, and this error is now given to the controller, and controller is giving the controlled output, and from which we get the manipulated output. This manipulated variable. So this is a manipulated process variable, and there is some disturbance variable is entering. So in spite of any disturbance entering, we are adjusting this manipulated variable so that we get always a level of always the y is equal to the set point. Okay. So this overall connection, everything. இது வரைக்கும் புரிஞ்சுதாப்பா? Time என்னாச்சு? Another only 5 minutes is left. Otherwise, we are simply representing this block diagram, or what is called, which is a flow and information diagram. This is, thanks, which is simply represented in terms of block diagram. இது வரைக்கும் புரிஞ்சுதாப்பா? எத்தனை பேர் கிளாஸ்ல ஃபாலோ பண்ணீங்கன்னு தெரியல. நீங்களும் வேற வரைஞ்சு பாத்தீங்கன்னா பெட்டரா இருந்திருக்கும். புரிஞ்சுதாமா? பவித்ரா? Thanks. So we are able to write in terms of block diagram only because of using Laplace transform. So otherwise this block diagram doesn't have much significance. So only because of this Laplace transform, this block diagram is now simply appearing as a algebraic blocks of algebraic, the informations, everything is now available in terms of simple blocks, and these blocks are easily understandable. So what is the output at this point? This is simply equal to this point multiplied by this point. Likewise, this is simply transferring this value. Whatever is entering is transformed by this amount, and we are getting this ys. And here this error is here we have a comparator, no, which is this is a plus and minus, and this is I'll better write this plus here, plus and minus. So this error is equal to set point minus measurement. Okay, இதோட continuation next classல பார்க்கலாம். Another about 2-3 minutes only left, and maybe இன்னொரு attendance எடுக்கிறதுக்கு I will enable this quiz again. One more quiz is coming up, so that attendance will be automatic, and I will make this.
Sir, கிளாஸ்ல சில பேர் வந்து வேல்யூ ஆடட் கோர்ஸ் ரெஜிஸ்டர் பண்ணிருக்காங்க சார். அவங்களுக்கு வந்து இப்ப வெனஸ்டே செகண்ட் பீரியட் இப்ப கிளாஸ் போயிருக்கு, சோ அதனால அட்டெண்ட் பண்ண முடியல இன்ஃபார்ம் பண்ண சொன்னாங்க.
சரிப்பா, தேங்க்ஸ்ப்பா ரோஷன். இன்னொரு இன்ஃபர்மேஷன் ஐ நீட் டு பாஸ் ஆன். திஸ் தேர்ட் அவர் கிளாஸ் இன்ஸ்டெட் ஆஃப் ஞானபிரகாஷ் சார், இவரு நம்ம ஹர்ஷா சார் கிளாஸ் இருப்பார். The third slot, no, which is from 11 to 12. Oh, 9:45, 10:45 class இருக்குல்ல. So okay, I thought class is over. Okay, another about 15 minutes time is there. Maybe ஒரு random check க்கு என்ன பண்ணலாம். Another quiz is available now. 1 minute, I will change the settings. So the quiz is visible now. You please simply answer that. The LMS la போயிட்டு first link simply refresh your link. யாரெல்லாம் முடியுமா பண்ணுங்க. Again we will continue because another about 10 minutes time is not there. 2 minutes break. 2 minutes break. That question is a very simple question only, and already answer முடிச்சிட்டீங்க நினைக்கிறேன் நிறைய பேர். Only one question is there, no? So even I can see the response of your previous quiz. எத்தனை பேர் மார்க் எடுத்தீங்க? Class average is only 0.87, which is very bad average. For the previous average morning first test க்கு வந்து average is only 0.87, which is only a real indication. Okay, still யாரெல்லாம் மார்க் எடுக்கணுமோ எடுத்துருக்கீங்க. குட். So I will consider this response to be more valuable, but though it is not going to be reflected in any of your test, at least if you want any feedback or anything, I will simply refer to this kind of test instead of the CAT 1 or CAT 2 or CAT 3. Okay, முடிஞ்சிச்சு நினைக்கிறேன். I will even close that link. Not more, அதுக்கு மேலே டைம் தேவையில்லை இல்லையா? I will make the setting. Okay, the quiz is over now. எத்தனை பேர் ஆன்சர் பண்ணிருக்கீங்க? Only 12 people have answered it. Quiz no open kada? I think I closed the quiz. Okay, no need to worry about that. I will continue this discussion. The discussion is again this closed loop. 1 minute. My LMS should be visible now. Even I can share from my system itself. Okay, I will. I don't want to have this blackboard. So I'm going to my system and system I will share. Okay, on the screen. Quiz come back to the class. Another about 10 minutes. Quickly, we'll done with today's discussion. So we have the representation of the feedback system. So the general representation is given here. So there is a process and there is a to the process, one of the variable is manipulated and another there is unmeasured thing, what is called as a disturbance. So the manipulated variable is adjust, the manipulation is coming because of this measurement controller combinations. So everything is represented in terms of the transfer function, this simple transfer function groups. And yeah, this final result is very important. Let us discuss that. So what is GP, GC? Always in the closed loop transfer function. This is right hand side is what is called as. There are two groups. Always this one. Always what is called as a closed loop transfer function. This first group is closed loop transfer function for the set point change, and the second group is closed loop transfer function for the disturbance change. So let us see the groups here. This is set point. Otherwise, this in the numerator we have what is it? GP, GF, GC for the set this YSP. Otherwise, this is simply otherwise GC, GF, GP, which is the multiplication. This is the multiplication of transfer functions in the forward direction. Starting from the set point, we have GC, GF, and GP. So GC, GF, and GP. Whereas for the disturbance variable, we have only GD in the forward direction. So that's why only GD. And for the denominator, we have 1 plus all the elements in the loop. So what are the transfer functions in the loop? GC, GF, GP, and GM. So GC, GF, GP, and GM. These are all in the loop. So otherwise given the block diagram representation of a control system, we can easily write this transfer function by having this logic. For the numerator, it is simply the multiplication of transfer function in the forward direction, whereas for the denominator, it is 1 plus all the elements in the loop. So whereas GD is not in the loop, that's why we don't have GD in the denominator. Is it understandable, Pa? Very simple logic. Of course, this is coming out because of the algebraic reduction. There is no magic here. We have connected everything. Even I can tell you how to connect it again also. Always Y of S equal to Y of S is coming from M of S into GP and D of S into GD. That to summation, and M of S is written in terms of C of S, and C of S is written in terms of E of S, and E of S is Y of set point minus Y of measurement, and Y of measurement is written in terms of Y of S. So everything is now connected. Okay, this is it understandable? புரிஞ்சிச்சு நினைக்கிறேன். ஓகே, புரிஞ்சிருக்கும். ஓகே, in connection with this, there are some simple rules available, what is called as block diagram reduction rules. So this is the kind we have seen so far, which is G1 in the something in the forward direction and something in the this loop or feedback in the return direction. So for this, yeah, I have also represented this. So this y at this point, or is y at this point is this is the y, and here we have G2 into y, and we here at this point this is going to be this input minus, or is this plus and minus are there, no? This is x in plus and G2y in the minus. So this is the information entering here, and it is getting multiplied by G1. So this is the thing. So otherwise y is simply equal to this group. So that is rearranged. Otherwise for the given x, how the y is coming? X equal x into G1 by 1 plus G1 G2 equal to y. So this reduction, or is this simply algebraic reduction? Nothing great we have done. So likewise, you can also prove that for a loop of this fashion, what is called as a positive feedback loop. But in a control system, we'll have only negative feedback. Only with a negative feedback we can have a control. Otherwise, suppose you have this information and that is again added with a set point, what will happen? The denominator will be going on minimum, and this output will be keep on increasing. So otherwise you won't have any control. Instead the output will be keep on shooting up. Okay, otherwise the feedback loop is simply a negative feedback loop. There is no positive feedback. Positive feedback will keep on increase the output, whereas we want to keep the output at steady. So likewise, these rules also you can go through. What is given here? This y this, instead of having this y at this point, we can also delay the introduction of y by this way. No, this is simply y added up. Instead of that, we can also show it as G2 raise what is the meaning of, what is the value of y at this point? This is going to be y into G2. So y into G2 is now available here. So otherwise, actually, whatever the process we had seen so far is of this pattern. This can also be represented in this way also. Otherwise, so there is some set point entering, there is a set point value, and there is a disturbance entering, and everything is acting on this transfer function G2. So these are all simply what is it, analogous representations. Okay. So from this we will continue, and we can also see another example, which is a response of stirred tank heater. So இதை வச்சு முடிச்சலாம். ஒரு 5 minutes we can see. So otherwise, instead of seeing the level system, okay, in addition to seeing a level system, we can also see temperature control system. So what is objective? We want to keep the tank temperature, tank temperature constant. Say there is an inflow entering, and heat in is to heat this level tank contents. We have say assume a steam heating system. So steam is entering in the coil. We can manipulate this steam input so as to keep the temperature constant, temperature of the system at constant, in spite of any changes in Ti. So Ti is now the load variable or the disturbance variable. Or is Ti is what is called as a D disturbance, and TST is your manipulated variable. Instead of TST, actually the what is it? This this amount, no, the my cursor point, no, this is the manipulated variable. So the manipulated variable and disturbance variable. So how it is manipulated? By taking a measurement of the temperature of the tank contents. So T measurement and set compared with the set point, and there is this information is given to the controller, temperature controller, and it is acting on the control valve. So there is a material flow, not only material as well as energy flow. Whereas steam, it is simply a energy flow. Steam is entering and leaving as condensate. So this is only energy flow. Whereas here we have material and energy flow. And these lines are simply in a line. These are all information lines. So some electrical signal, and there is a pneumatic signal. This electrical signal is shown by this line, whereas this is your pneumatic signal, dash line. No? So for this, we can make the energy balance. Assuming, okay, we to simplify the problem, we have this constant density system and constant volume. Otherwise, the level of the system is constant. And constant flow for simplicity. We are having these restrictions: constant density, constant volume, constant flow, which means we need not write mass balance again. Mass in equal to mass out. So we can simply write energy balance. So what is the energy balance? Energy in by the flow and energy leaving is which is equal to msubbu. Everything with a reference to a temperature of T ref, and energy added by the steam, which is given as energy added by the steam is UA into delta T, which is equal to the change of accumulation, change of energy in the system. So this you can reduce, and at last we have this kind of thing. So here your TI is the manipulated variable, and TEST is the, this is the manipulated variable, this is the load variable or disturbance variable. So both are getting added up. There is temperature, output temperature depends on the steam temperature as well as the inlet temperature. We have this block diagram to represent the control system. We have seen two examples. One is from the level system, another from the stirred tank heater. Why do we say it is stirred tank? Or is entire condenser are kept at uniform temperature by some sort of mixing. Even you don't need any mixing in the case of any small system. You can have a mixing even by the vigorous heating action itself. Okay, this is very important. And from this onwards, we'll continue. And in the next class, we'll discuss about the GC, what is called as a transfer function of the controller. The transfer function of the measurement, I need not discuss much, because you can take this measurement as from a manometer or a thermometer. So that dynamics are known to you. And GF also you can consider to be this control valve. That also we won't discuss. We will discuss about GC in the coming class. And we'll directly go to the effect of controller on the system. Okay, that's a topic of discussion in the coming class. Okay, class purinjidappa idvarike any discussion needed?